got not very many donuts, but tons of coffee. Yeah. B's got a little bit of both, less coffee but more donuts. C's got a ton of donuts but very little coffee. I'm like, yeah, but which one do you want the most? Which one would make you most happy? They're like, it's just like they're all the same to me. Like I would be equally happy with all of those. Yeah. So all the points along a given indifference curve give the consumer the same level of utility. The consumer is therefore indifferent between them, and that's why it's called an indifference curve. Yeah. Make sense? I'll talk about why it has this shape momentarily. Okay, so for any given indifference curve, the consumer is indifferent between all points on it, but the consumer actually has more than one indifference curve. They have a whole indifference curve like map, right? So there's more than one indifference curve. So for instance, there's some other indifference curve, say out here, yeah, and I'll kind of be imprecise about this, but in general, I'll draw indifference curves that are roughly parallel to each other, at least. I think in your book somewhere there's an exercise that says like that you construct a little proof that they can't cross. At the very least, they can't cross. And so, this is somewhat imprecise diagram, but in general, I'll draw them roughly parallel to each other and never crossing. Yeah. Okay, so there's this other indifference curve, and just like this indifference curve, the consumer is indifferent between all the different bundles of coffee and donuts along the indifference curve. But which indifference curve would they rather be on? No. It's the one that's further out. Yeah. Because kind of like we were just doing with, the ABC example, right? There's just more of everything on this one. Yeah. So the consumer wants to be on the indifference curve that's kind of as far away from the origin as possible. Yeah. So maybe all the points on this first indifference curve gave the consumer utility of 20. Maybe all the points on this one give them utility of 30. Yeah. Okay, so that's like conceptually what an indifference curve is. Does it make sense? Yeah. Okay. Let's talk a little bit about like the math behind the slope of an indifference curve. Yeah. Which will kind of like the fact that the slope of the budget constraint is the inverse of the price ratio. Will seem kind of like, why are we doing this? But then it'll come back in an important way in like 10 minutes. Yeah. Okay. What do I want to say? Actually, before I do that, let's talk about why the indifference curve has this shape. Unless one of you wants to just get it. Like if I said, why is it shaped like this? Why isn't it a line or something? What's your shortest? What's your answer? Any ideas?
Wasn't there like some diminishing rate of substitution, something like that?
Yeah. Yeah. So there is like the slope of this thing is called the margin rate of substitution. Yes, diminishing marginal utility turns out to be the reason. Yeah, this idea that like when you're eating tacos, the first taco tastes great, and the second taco tastes good, and the third taco tastes like okay, and then eventually like the extra utility you derive from consuming an additional taco gets smaller and smaller, and eventually gets to zero maybe, or even goes negative if you kept eating them. Yeah, you'd be like me puking on the side of the road, with food poisoning or something. Right. That actually is that idea of diminishing marginal utility is why it's shaped like this. Yeah. So like maybe one way to see that is to consider 2 points. So we already have A and C up here, and let's focus on those. So let's say that like the consumer's at point A, yeah, and you say, hey consumer, bad news, I'm taking away 1 donut from you. Yeah. So you're gonna go from here and you're gonna go over 1. Yeah. Then you say, good news too, don't worry. I'm going to compensate you for taking away that donut by giving you more coffee. And you ask them, how much coffee do I have to give you to leave you as happy as you were before I took away your donut? Yeah? So said differently, that's saying, how much coffee do I have to give you to put you on the same indifference curve you were on before? Yeah? And the answer is this vertical distance. Yeah? And it's kind of a lot from point A. Yeah, if you say if you're gonna take away 1 donut from me, you have to give me a lot of coffee to make me as happy as I was before you took my donut. Yeah. Okay. On the other hand, if they're at point C on the same indifference curve, yeah, and you do a similar exercise, right? You say I'm gonna take away 1 donut from you, so I'll try to draw that the same horizontal distance. That's 1. And you say, But again, don't worry, I'm going to give you some coffee to keep you as happy as you were before. How much coffee do I have to give you? The answer is only like this much to keep them on the same indifference curve. Yeah? So it's a lot less. Right? What's the difference between point A and point C?
Point C, they already have a lot of donuts, but point A, they don't.
Yeah. Right? At point C, they have lots of donuts, and conversely, they don't have much coffee. Yeah. And so they're like, oh, you took away my donut, but I'm already kind of satiated with donuts. On the other hand, I could really use some coffee. I don't have very much. Yeah. The marginal utility of coffee is high for me because I only am consuming a little bit right now. The marginal utility of donuts as well. So you only have to compensate me a little bit. On the other hand, up here, right, the consumer has lots of coffee and relatively few donuts. And so their marginal utility of coffee is low and their marginal utility of donuts is high. Yeah. And so to take away one donut, you have to give them lots of coffee because you're taking away the relatively scarce good and giving them the relatively plentiful good. Yeah. So the fact that they have this shape, yeah, is exactly the idea of diminishing marginal utility. That the first taco is better than the fifth. Yeah. What if a consumer did not have diminishing marginal utility? What if the marginal utility of donuts did not depend on how many donuts you've had, and similarly for coffee? What would this thing look like? Yeah, it would be linear, right? It would look like this. And then the rate at which the consumer trades off coffee for donuts while remaining equally happy is just constant. Yeah. And there's other special cases, but in general we'll draw them with this shape. Yeah, because we think diminishing marginal utility is the norm. Yeah. Okay. Now let's digress for a moment and talk about the slope. Let's see. So the slope, as usual, is the rise over the run. Yeah. So we want to know the slope of this thing at any given point. The slope of an indifference curve, in general, is the change in coffee divided by the change in donuts. Yeah. To get a somewhat useful expression for that, I'm going to do something a little different, right? Which is to say, okay, if I'm going to write an equation for an indifference curve, it could look something like this, right? And just bear with me, this might not be immediately obvious why it's true. I could say that the change in coffee times the marginal utility of coffee, yeah, along an indifference curve, plus the change in donuts times the marginal utility of donuts, yeah, that these have to sum to 0. Yeah? So it's saying, it's just like this example. If I take away a donut but give you some coffee while keeping you equally well off, another way of saying it is that these two things have to sum to 0, right? So it's saying, the change in the number of coffees you have times how happy those coffees make you, right? This is like I gave you an extra coffee, one extra coffee, so delta C is 1. How much extra happiness did you get from that? Well, that's the marginal utility of coffee, right? Then over here, it's like the change in donuts would be some negative. I took away some donuts. And, how sad did that make you? Well, that's the marginal utility of donuts. Yeah? Those two things, along an indifference curve, have to exactly offset each other. Yeah, they have to sum to 0. Yeah? Okay. Then I can rearrange this a tiny. I can do a little bit of algebra with this to try to get to something like this. So maybe I'll move the donut terms to the other side. So I'll say delta C, times the marginal utility of C is equal to the negative of delta D times the marginal utility of D. And then I'll divide both sides by delta D. And also divide both sides by marginal utility of C. So I could get something like, sorry, this is not great board management. It's delta C divided by negative delta D is equal to the marginal utility of D divided by the marginal utility of C. Yeah. And that's the slope of an indifference curve. So the slope of an indifference curve, right? Because this is rise over run, yeah. So the slope of an indifference curve, right, is the ratio of marginal utilities, and that seems kind of abstract right now, but it'll come back in a second in a way that's important, yeah. But like conceptually, the slope of an indifference curve is the rate at which the consumer can trade off one good for another while remaining equally well off. Yeah? And that rate at which they can trade off one good for the other while remaining equally happy is nonlinear because of diminishing marginal utility. That's why these are not lines. Yeah? Okay. So, the budget constraint was the ratio of the prices. That's how the consumer can trade off one good for the other given their prices. Yeah? And this is, the slope of the indifference curve is the rate at which the consumer can trade off one good for the other while remaining equally happy. Yeah. Okay, so those are the basic components of the model. No questions at this juncture? Yeah. Okay, let's put them together and think about what we're actually interested in, which is what will the consumer do? Yeah? Like how many coffees will they choose to eat, and how many donuts will they choose, or how many coffees will they choose to drink, and how many donuts will they choose to eat, given their preferences